So this is a problem here out of 6.3, and it says a researcher wishes to estimate with, 99% confidence the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 2% of the true proportion. Part A says no preliminary estimate is available. Find the minimum sample size needed. Okay, so in order for me to do this, guys, what I'm going to do, this is the notes from 6.3, and here is my formula that we're going to use, okay? And so I'm just going to come back, I'm going to copy this here and write it down. So n equals p hat q hat times zc over e all squared. So n equals p hat q hat times zc over e, all of this is squared, okay? All right, so the first part here says within 99% confidence. Okay, so let's get a picture of what that's going to look like. Here's my normal curve, right? So what we're saying is that this area here is going to be 99%. So again, remember what that means. That means that there is 1% available for each of those little pieces. So if I take 1% and divide it by 2, I'm going to have 0.005. So that's going to be the area that's over here. And now what I need to do is I need to find my critical value, right? So in order for me to find my critical value, I'm going to use my inverse norm function at 0.005, right? So let me get my calculator here. Okay, let me get out of all this stuff. So done. Okay, so we're going to go second bars. We're going to go to inverse norm, 0.005, hit enter, and to 2 decimal places, I'm coming up with negative 2.58. Negative 2.58 is that value right here. Negative 2.58, okay? So now let's take a look. And so to do part A, it says no preliminary estimate is available. So if I come back to my formula, I want you to look here. It says assuming you have point estimates p hat and q hat, otherwise use p hat and q hat to be 0.5 of each. Okay, so when we don't have preliminary estimates, those are the values we're going to use. So we're going to say n is equal to 0.5 times another 0.5 times, let's see, so my critical value is going to be, 2.58 over my error. My error is 2%, okay? So the error is 2%. As a decimal, that's 0.02. And this is going to be squared. Okay, so let me take my calculator again, and I'm going to type in this exactly as I see it, okay? So getting the calculator again, let me clear, I'm going to go 0.5 times 0.5 times parentheses, 2.58, 58, why is my 5 not working? 58, there we go. Divided by 0.02, close it off, square it, and hit enter, and I'm coming up with 41,602.5. In these cases, we should always be rounding up. So I'm going to take 41,603. And so my answer should be 41,603. Okay. Let's see. Part B says, what's the minimum sample size needed if the prior study found that 38% is responsible? Okay. So then in part B, the only thing that's going to be different, let me do part B in blue, is that my n now, my p hat is going to be 0.38. So then my q hat is going to be 0.62, right? Because I'm taking 1 minus this value. So 0.38 times 0.62. Everything else stays the same. Okay, and so now I'm going to go ahead and do this calculation, 0.38. Okay, so I told you what we can do. We can go second entry, and then just change. You know what? I realized I made a mistake in the first one. I forgot to do 0.5. Oops, okay, so I'm glad I saw that. Okay, So let me redo the first part, guys, because that was my mistake. I missed that. Forgot to put the point. Oops. All right, so let's square it, and there we go. So 4160 point. So 4160. Let me see. 4160. I went back. I lost it already. I would say 4161. Usually it tells me to round up to the nearest whole number. So let me erase this here. And for part A, 4161. Okay, so let's come back and do part B. Here we go, second entry. And we're gonna change these values, second insert. So this is 0.38. And delete that one. And then this was 62. Okay, delete that one. And everything else should be the same. And here I'm coming up with 3,921. 3921 for part